So that's how we can define and then also call functions. Now, functions can do more than accept a couple of parameters and then do something. For one, they of course don't have to accept any parameters at all if you don't need any input values, but this function, for example, needs some. But they can also, in addition, produce values and return values so that you can call a function, get back a value, and then use that value in your other code. And that's, for example, what this mathPOW function does. It calculates a new value based on these two inputs, these two arguments that have to be passed to the function. And then this POW function generates a new value and returns that value, which is then used here in that place where that function is used. So that we multiply investment amount with the return value of this function. And of course, we can also build our own function that returns a value. And we could, for example, do that to outsource this calculation logic into separate functions. So we can add another new function, which could be called calculate future value. And this then should be a function that performs this calculation. So of course, we can copy that code, that operation here, that calculation code, and paste that in here. And then you can add the return keyword in front of that, which is a built-in special keyword recognized by Go, which will tell Go that this value should be returned as a result by this function. Now in Go, unlike in many other programming languages, you can actually pretty easily return multiple values, simply by separating them with a comma here. So we could, for example, name this calculate future values to be a bit more descriptive for what it should do, because then in addition, we could return this inflation adjusted future value. So we can copy this and then add this after this comma as a second returned value. So now this function returns two values. Now, since this is a bit hard to read, if this is all in one line, we can then of course also create some variables in here and get our future value, which I'll just name fv here, which stores the result of this first calculation here. And then our real future value, rfv, which stores this result. And then we can just return fv, rfv. But as you see, I'm also getting some errors here, because I'm now referring to some variables in here which are not defined inside of that function. Investment amount, expected return rate, and so on are not defined in here. Instead, they are defined inside the main function, and therefore they are scoped to that function. Because in Go, as in many other programming languages, any variables or constants that are declared in a function are scoped to that function and are only available in that function. Now, what you could do is, for example, you could grab that inflation rate constant, cut that from the main function, and then either add it to this calculate future values function, or if you maybe need it in another function as well in the future, you instead put it on a higher level in your code, outside of any function, right into the code file like this. Now, this does not work with all code. For example, we can't call a function here. This does not work. This has to go into another function instead. But you can add constant and variable declarations outside of any functions right into the code file like this. And when you do that, that constant or variable is scoped to the entire code file instead of a specific function, and is therefore available in all the functions of that file. So now inflation rate, for example, is available down there, and we're no longer getting an error for it down here. Now we could therefore do that with all these variables and also move those outside of any functions, though as you see here, you then can't use this shortcut for defining a variable. Instead, you'll now have to do that with the var keyword, like this. And with that, all these variables would be scoped to the entire file. However, that's not what I want to do here. I'll do that for that constant, since that will never change, but I'll not do it for the other variables. Because instead, I'll add these variables here because they will be defined, they will be set in that main function. So I want to keep them close to that place instead of declaring them as global variables, because if we would actually declare them outside of main like this, we could theoretically execute this code here where we use these variables before they have been set. Keep in mind that investment amount and years initially have no values, so they have a default null value, which in case of floats is the number 0, but they don't have the value we need for this program. Therefore, to make sure that under no circumstances I'm accidentally calling this function here without the proper values being set for those variables, I'll move that code back into the main function, and we can then also go back to this shorter notation if we want to. And I'll instead get those values into calculate future values by accepting some parameters here, just as we did it with output text. So here in calculate future values, we can now expect the investment amount, which should be a float 64 value. Then as a second parameter, this expected return rate, which should be a float 64 value. And then also the years, which should be a float 64 value. Since we have the same type of value for all three parameters, we can then also shorten this, as you learned. And with that, most of our errors down here went away. Now we have one more error here, because I'm referring to future value, but I now named it fv, so we should use this name here as well. And once I do that, all the errors in these two lines went away. But now we got new errors here. And the problem down here is that now we actually return too many values. Because we actually do return two floats here when we shouldn't return any. But wait a second, why shouldn't we return any values? We do have that return keyword here, and I mentioned that you can return values in your Go functions. Well, you can, but since it's a statically typed, type-safe language, you have to define your intention regarding which kind of values you plan to return in a function when you start defining that function. Here in this line, you don't just have to give this function a name and define any parameters needed, but instead, you also must add the return types here before you open the curly braces, but after your normal parentheses. And here you would add float 64 if you would return one float 64 value, or if you return two, you have to wrap that with parentheses, separate it with a comma, and add a second float 64 type. Or whichever types your functions return. Here it's twice float 64. If you had a function that returns float 64 and an int, you would write it like this. But again, here we need float 64. And with that, the error now did go away. Now we can use this newly added calculate future values function and call it in our main function. By adding parentheses like this, that's how you call a function, and by then passing our input values to that function. And here, if we hover over this again, we can see that as a first argument, we need to pass in the investment amount, as a second argument, the return rate, and as a last argument, the years. So let's do that. Investment amount, expected return rate, and years. And that's how we call this function. But since this function now also returns two values, we of course should use these values somehow. And here I want to use them by storing them in new variables, to be precise in these two variables, which we then use in the code thereafter. And indeed, if a function returns a value, you can simply store that value in a variable. So here, I'll store it in future value. If a function returns two values, you have to define multiple variables separated by a comma, so that I also have my future real value here. And then the first returned value will be stored in the first variable, and the second returned value, as you might guess, in the second variable. And that's how we can outsource these calculations into a function. Of course, alternatively, we could have also created two functions, one for each calculation, but since I wanted to show you this feature of returning multiple values, I went for one function here.